Hello students. In this particular video I am going to cover condition for maximum efficiency. Particularly for our syllabus, this derivation is not mentioned in the syllabus, even though that derivation is not there, but particularly the condition of for maximum efficiency we should know in order to solve the numericals. As we all know that when the efficiency will be maximum, the many people will give answer whenever losses are less, the efficiency will be maximum. That is what the general answer is what we used to give, but that is not true in our transformer cases. In transformer case, the condition for maximum efficiency is not the less losses. It is whenever the core loss becomes equal to copper loss, or copper loss becomes equal to the core loss, the efficiency of the transformer will be maximum. And this condition we can understand with the help of derivation. There is a small derivation is there, so that we need to derive it, then only we will come to know that why efficiency of the transformer will be maximum when copper loss becomes equal to iron loss. So in order to derive this derivation, we need to consider some points. See, basically efficiency is a function of load, and load is nothing but load current I2, because we have already studied efficiency derivation in last class. In that we have got the equation V2 I2 cos phi 2 divided by V2 I2 cos phi 2 plus Pi plus I2 square into R2E. Here if you consider V2 secondary voltage is constant and power factor cos phi 2 is also constant, then I2 is the only variable term. Hence the efficiency is the function of load current. To get maximum efficiency, we need to differentiate that efficiency term with respect to that current function I2, and we have to equate it to 0. Then we can achieve the condition for maximum efficiency. So let us start deriving that differentiation. To derive that, what I have considered, I have deriving, that means I am differentiating that efficiency term with respect to current, and I am equating it to 0, so to get the condition for maximum efficiency. Where efficiency, as you all know, V2 I2 cos phi 2 divided by V2 I2 cos phi 2 plus Pi plus I2 square into R2E. Here this is in the form of u by v, so you can use u by v derivative formula, and you start derivating this particular expression. So what we are going to get, that u by v formula is nothing but v into du by dx or dt, and minus u into d by dx divided by v square is equal to 0. This is what the formula of u by v. Now here v is this denominator term, I will keep it as it is only. Then I will differentiate this numerator term, that is u, so with respect to I2, so I will write v2 I2 cos phi 2, I need to differentiate, minus now u is as it is v2 I2 cos phi 2, I am keeping it constant. Now I am derivating this numerator full term with respect to I2, so I am writing here v2 I2 cos phi 2 plus Pi plus I2 square R2E is equal to 0 divided by v square, that v square will go to this 0 side, hence the no need to use it, so hence I have not written that v square term here and that denominator term. Now if you differentiate, what you are going to get, this term remains same here. Then if you differentiate this term, here I2 is the only one term, so with respect to I2 if you differentiate, then you are going to get v2 cos phi 2, so v2 cos phi 2 you are getting, minus v2 I2 cos phi 2 you are keeping it constant, and differentiating this term with respect to I2, so this first term will remains as it is, v2 cos phi 2 plus Pi is what? Iron loss. Iron loss is called what? Constant loss. So constant is nothing but it is a 0 plus I2 square into R2E. So I2 square is nothing but x square. So x square is 2x. In the similar way, I2 square is nothing but 2I2 into R2E is equal to 0. So now you have differentiated all the terms. Now next thing is, take V2 cos phi 2 is common. Take V2 cos phi 2 and V2 cos phi 2 from this. So what happens? Take V2 cos phi 2. So this particular term as it is, it remains same. So it remains same, V2 I2 cos phi 2 plus Pi plus I2 square R2E. Now next one is minus. Keep it that minus as it is. Now from this term also take V2 cos phi 2 as a common already taken. The remaining term is I2. This I2 you need to multiply with this term as well as this term. So it becomes V2 I2 cos phi 2 and this becomes 2 I2 square R2. That is only here it is written V2 I2 cos phi 2 minus 2 I2 square into R2E is equal to 0. Now taking this V2 cos phi 2 over to the 0 side, so it becomes, taking this V2 cos phi 2 over to the 0 side, the expression becomes V2 I2 cos phi 2 Pi plus I2 square R2E minus V2 I2 cos phi 2 as same and minus 2 I2 square R2E is equal to 0. Now this is plus V2 I2 cos phi 2 and this is minus V2 I2 cos phi 2 get cancel each other, and here I2 square R2E is there and here 2 I2 square R2E is there. So one is cancelled here and this one is get cancelled. So what is remaining? Pi minus and 1 I2 square into R2E is remaining. So Pi minus I2 square into R2E is equal to 0. So Pi is equal to, if you send this I2 square this side, it becomes positive. So I2 square into R2E. So Pi is equal to nothing but PCU. PCU is nothing but what? Copper loss. Copper loss, how you denote? I square R. I square R is nothing but what? Here it is a secondary side we are talking. So I2 square into R2E. Refer to secondary side, we have written the equation. So I2 square into R2E, it is nothing but copper loss. So whenever iron loss become equal to copper loss or else, we need to define in this way. Whenever this copper loss become equal to iron loss, the efficiency of the transformer will be maximum. This is the condition for maximum efficiency. In some numerical, they will give to determine the maximum efficiency. Whenever you are determining the maximum efficiency, you should use this particular condition: Pi is equal to PCU, Wi is equal to WCU, or iron loss is equal to copper loss. This particular condition you have to use and you have to determine the maximum efficiency. Only for our syllabus we should understand or we should know copper loss become equals to iron loss, the efficiency of the transformer will be maximum. But if I explain only this much only, so you will not be able to understand how it that iron loss becomes equal to copper loss. Hence I have derived this derivation. This derivation is not there for your syllabus, but even though this conditions they are going to ask in the numerical point of view. So for that numerical point of view, this condition you should know. So to understand that condition we need to derive. So hence I have derived it. So try to remember, try to use this particular condition in these numericals to get the maximum efficiency. I hope everything is clear. If not, please ask me. Please write some comments in the comment box, and definitely I will try to explain you if you are not understanding. With this explanation, I will finish this lecture. Thank you.